Hey guys, how's everything going? Let's continue our journey to LeetCode programming questions. Today, let's take a look at number 90, subsets 2. This is actually a similar question, which is, I think this one, subsets, because this is 2, so the original subsets problem is 70, I think, 78. So actually we have done that before. Please search on my channel for the detailed explanation. And let's just review the problem again. We're given a collection of integers that might contain duplicates. Nums return all possible subsets. The solution set must not contain duplicate subsets. So, for example, we're given 1, 2, 2. So all the possible subsets would be, of course, the empty set, and the sets with one integer, which is 1, 2. And because the third one is these two are the same, so we only the only 1, 2, and then sets with two numbers 1, 2, 2, 2, and sets with three numbers 1, 2, 2. Okay. The core idea, I think it's the same as the previous one. I'll just review it again. So for a number, for any number like A, B, C, for all the par set, let's just consider the most basic process, which is picking a number, right? Let's say for the first number, which one it would be? It would be A. There would be three cases for the first number, right? The first one is A, B, C. If we pick them up, so what's the next one would be? The next number would be one of the rest numbers, right? So the problem is could be done in a recursion, which means the first step is that we will pick a number randomly between this A, B, C. This is a pick a number. Pick a number. And then pick a number from the rest. And then do it over and over again until there is no number. No number left. So actually we were doing we were generating the permutation, right? The permutation actually. The intermediate result would be all the par set, right? So the permutation of here is 2, 2, 1, but the 2, 2 is the intermediate result, and 1, 2, 2, and also 1, 2, 2 is the same. Yeah, so we're gonna do as what we did before, but we will rename it the recursion function from walk. At that time, I thought a walk is a very, how to say, easy a phrase, a word that is easy to understand. But now I think I will use a new name called pick. The parameters were the same as before. One is current, and the second one is a rest number. Rest. This function, what this function does is it pick a number from the rest and put it in the current array, right? And so we will start with pick. The current is empty, yeah, and the rest will be nums. Pick a number here and put it in the current, and then do it like over and over again, and finally return the result, and the result would be empty. For every time when we pick some number, what we do the first is we will push the current, which is the intermediate result, into the result, and then we will loop through all the numbers for let index a smaller than rest dot length I++. We will pick this number into current, and pick it again, right? So will be pick current concat rest I, which is the new current, and the rest. So the rest would be rest slice slice I plus 1. Well, I had to say it's not very cool to use slice because it's create a new array, and I would say because the array would not change at all, so we use the index start as the start index of this the rest, right? So the start would here would be 0, and for I would be start from start. The nums would be nums.length I start I plus plus current rest, not rest but nums, and then the next one would be I plus 1. So this is actually the original solution for our previous problem. But this solution has only one caveat, that it doesn't support the duplicate numbers. For case here, we will pick 1 down, pick 1, and then pick 2, and then we will pick 2 again. So that generates duplicates. How we can do that? Of course, when we're doing the pick here, we need to do some, how to say, to avoid extra picking. The naive idea came to my mind is that if we met this kind of 2, right? The first 2 will be valid. We can just how to say, we just continue. But when we met the second 2, it means these 2 actually is totally the same round, right? For this for loop. For this for loop, it means the current will be, how to say, the current would be like 1, and then we pick 2, like start with 1, and pick 2, and then we'll contact 2 again. So actually we could skip it. It means if nums I if equal to the previous one, it means the same, right? We should continue. But here's the problem. We're not guaranteed that the input is sorted, so we need to sort it by ourselves. So num sort. So now all the numbers will apply this rule. If it is previous one, we continue. If for the other case, we will pick a new. We will only continue picking new numbers for the rest, right? Yeah, I think this should work. Let's do it. Let's try. Oh, -1. My bad. Here's a problem that actually we're not creating new array. So when we are checking the first element in this for loop, the start might be the same as the start -1. So we need to extra check which is I is bigger than start. Yeah. Yeah, I think we're gonna be accepted. Let's analyze for the time and space complexity. First we use sort. So the sort, what's the time complexity for sort? I think it should be n, which means n. What is it? N log n, right? For the sorting method, right? We can do it in a quick sort. I don't know, which is swapping. If cut in half sort. Oh man, I forgot what's the time complexity of sorting method. It should be like this, right? The basic idea is that we pick the biggest one and put it at the beginning, or the smallest one at the beginning. So it would be n square. Yeah. But if you use quicksort, what is quicksort? Well, it's another topic. I think it's just comparing the head and the rear. If the big, we put it before. Put it at the beginning. If it's small, if the order is not right, we swap it. So every time we will assure that the order of two numbers are assured. Okay, if they're okay, compare the next one. Every time. Well, I think. Well, I need to learn that again. Anyway, I think it should be like this. And here, for every pick, it's recursion. So you will use extra call stack. This would be the call stack. The length would be call stack on. The depth will be on. So because it will go down to the n and then be popped, so the maximum would be on, big On. And here is for loop. This would be on. So the time complexity would be actually every time we will generate a new result. So actually the result would be time would be O2n, right? Either exist or not. Okay, so that's all for this problem. Hope it helps. I need to learn the sorting method again. And okay, see you next time. Bye bye.